Okay, welcome back, and let's begin. All right, more stuff about lists. Yeah, guess what? Lists are not going away ever for the rest of this semester, or really any other further programming language you ever deal with. They basically stick around. The only thing that might be a little bit funny is for those who carry on and do the DSAI 2201 course, which I guess is pretty much everybody here, eventually you will probably see something else called NumPy arrays, but really they're just lists. But they're lists in disguise to make things faster. Okay, so yes, lists are very, very critical. They are incredibly useful. That's why we continue to push on them for a really long time. All right, so I believe what we have is we have a couple of slides in here, but as usual, it'll probably be just one or two, and then we'll quickly diverge over while we try things, because demonstrations can certainly make things stand out easier than some slides can. All right, there's a whole bunch of common list methods, okay, and what these are, we saw one of them previous class. We looked at the first one that I put up there called append. And what it does is it adds a new item at the end of an existing list. So just to remind you how this works, and then I'll cover the other ones, but it will make a lot more sense, I think, if we actually see the code run rather than just looking at some slides. All right, so once again, just a quick little thing. I just do this content. That's very nice. Here we go. Right, make that just a touch bigger. Okay, so off we go. We need some lists. Okay, so here we go. Test scores, because that's what we've been using. So 67, 87, 43, 90, 77, 90. Yes, you're allowed to have more than one value of the same type. Quite often I miss it. And a 45. Okay, here we go. There's a bunch of test scores. All right, and the very first exercise I showed you yesterday, or sorry, the first method I showed you 2 days ago now, sorry, was called append. Okay, if you put an append 50 and you print it out, scores. All right, what you end up getting is you get exactly the same list, but it has been modified. Okay, and one extra value has been tagged on to the end. Okay, so there you go. That's the first one. That append is probably the most important method. Everybody learns it very quickly because guess what? We use it all the time. The next few methods I'm going to show you, I'll be honest, we don't use them a whole lot. Okay, but if you need them, they're here. So they are useful. You do need to know them. It's just they're not used nearly as often as, say, an append. So my proposal is I do like one at a time. All right, so nobody asked me this question yet, and I suppose there's 2 or 3 different ways how it can be done, and that is, well, what if I wanted to put a new 50 in here, but I wanted it to be put at the very beginning of the list rather than at the end? The dot end is easy because it's just a dot append, but if you really wanted to put something at the beginning, the operation is called insert. The insert operation takes 2 parameters that you have to provide. The first parameter is the position. Okay, so I'll write it this way as POS. It doesn't exist yet. And the second is value. That's the general case. Okay, so when I'm talking about putting something at the beginning, where's the beginning? 0. Okay, and what I'll do is I'll stick a 99 right at the beginning because it'll definitely stand out. And that's exactly what it does. Yes, something goes at the beginning, and yeah, everything else stays in the list, and everything goes forward by 1 step. Okay, so at the end, append. At the beginning, insert. Oh, but of course you can insert wherever you want to insert. For example, if I wanted to, I could say please insert it into position number 6, and it will end up going there. Oh, I suppose what I better ask is what happens if I insert a position 7? Ooh, 0, 1, 2, 3, 4, 5, 6. Okay, so that's why you put it there. What do you think happens if I ask for 7? Okay, that's a good guess. It goes to the end. It certainly seems reasonable to me. Let's find out if it does it. Okay, yeah, that's at least consistent. All right, I suppose what I should do is I should ask for a -1. What do you think? Probably still at the end. Again, that seems pretty reasonable. Just give me a second. I'll get rid of that bar. Yep, you go away. There we go. Excellent. Okay, so nothing weird about this one. And -2? Yeah, so it's the same thing as using the positive numbers. Okay, so the 99 goes as second last. Okay, now the question becomes is what if I ask for 8? Yeah, so insert 99 position number 8. But remember, what's that position 8? This is 0, 1, 2, 3, 4, 5, 6. It sounds like it's going to be an out of index thing to me. All right, so let's take a look. No. It's one weird thing, so it's a little bit of an anomaly. I would actually have expected that to be something that you'd end up with an out of bounds exception because there is nothing there. In fact, well, what happens if I just make this absolutely crazy, like position number 34? Okay, so here, we'll clear it so that it's absolutely clear, and yeah, it just adds it to the end. So you can stick a really big number and it sticks it at the end. Okay, useful trivia? Yeah, maybe. Unfortunately, it's a very specific Python thing. There are other languages that if you do something like this and you actually stick the value 99 in the position 34, it'll actually fill everything else with zeros. This is not the way it works here. All right, but it's here in case you ever get a question like this. All right, second one up. We did this one the other day. What? Okay, a remove. Okay, if I ask the remove 90, it removes the first 90 that it finds. What if you ask for something that isn't there? Like, for example, if you ask to remove 9,777? Yeah, that's an error because it's not in the list. Okay, good. You remember that from last time. All right, it was just here again. All right, and if you remember, I also included something called pop. Okay, as opposed to remove one, now I've got something called pop one. The difference between a remove you specify the value you want to get rid of. The pop, you specify the location. Okay, so this says, please remove the element that's at position number 1. So when I run this, hopefully we end up seeing that the number 87 has disappeared and everything is shifted around to make up for it. All right, and I guess there's one extra thing here. I don't know why it's here, but that's all right. We will do it. There's an operation called count. Okay, and what it will do is it counts how many elements. Okay, and when I run it, what do we see? Exactly the same thing because it doesn't make any adjustments. The way how this works is it returns a value, so I'll just call it x, and I'll print x so you can see what it is. It says that there's 2 of them. So basically you're asking, okay, how many 90s are there? Yeah, there's 2 of them. And what about that number right there? How many of those are there? 0. Or is it an error? Yeah, it's 0. It actually returns a 0 this time. All right, good. So if you're using count, you don't need to check that. There is a whole pile of these things, by the way. These are kind of the most common ones that show up. I'm going to describe it as showing up in the course. And in terms of actual programming, I don't use many of them, but these are the ones that quite often show up for tracing questions. But you see, if I ask for help on a list, you'll actually get absolutely everything. So just to give you an idea what's here. Yeah, there's an operation called append. Good, we know what that is. There's an operation called clear. It removes everything. There's an operation called copy. We'll see. But here's the count. There's something called extend. Okay, I know it's in the slides. There's something called index. I think I showed pop. We showed remove. We showed. We didn't see reverse or sort. We'll see them when we need them. Okay, so yeah, I'll actually cover most of them, but only as we require them. Okay, oh, and here's my super favorite slide. Okay, eventually it had to pop up. Okay, I don't know if they're still using this word in INFSC 1101. I know it used to be used, I won't call it everywhere, in 1201, but it would always be a couple of slides where they'd bring out the statement and saying, strings are immutable. Okay? And the example would look like this. So I might as well go back because maybe this is how it was done. So this is true, by the way. Strings are immutable. Let's just have a, here you go. Here's a variable called variable. Okay. All right, so here we go. The way it's normally provided. If I ask for variable at location 0 and I run it, what do I get? Yeah, get an H. Okay, very good. So that's the very first letter. If I said variable at 0 is equal to Y, and I print variable, the whole thing. So the very first time we see an H, the second print prints. Actually, it never makes it. Okay, and that's because you can't modify an individual element of a string. All right, and the claim is always it's because it's immutable. That's actually not the reason why. I mean, it is partially the reason for it, but it's actually because they didn't support item assignment. Okay, all right. Now, unfortunately, the word mutable shows up here, so now I have to try and wave my arms and try to get you to understand what it means to have something that is mutable and what the side effects really mean when something is mutable. There's a couple of places where it shows up that's very, very important. Okay, and don't worry, I'm never going to ask the question, is the following thing mutable? Okay, I don't ask questions like this, but there could be things that happen. In fact, you've already seen it, you just didn't know yet. Okay, and I don't have the ability to even demonstrate it yet, so this mutability comes back a couple of times. All right. Okay, what do I want to do? I was just thinking, what was I going to do? Right. Okay, typical variable x, 45. Okay, that's just a variable. All right, can you change the value of x? Yeah, of course you can, right? So if I print x here, there you go, and I print the value of x here. All right, you're going to see it has two different values. Perfect. So x first had the value 45, and then it had 54,000 some. Excellent. So is it the same variable? And you're going to say, of course it is. It's called x. In reality, it isn't, because it turns out that variables, integers, are actually non-mutable. Okay, watch this. This will absolutely blow your mind. And by the way, I don't ask these questions either. This is just me trying to describe, because I have to demonstrate one important property of this. All right, print 45 is not a problem. Have you ever seen the operation called ID? Okay, so that's fine. It's not a requirement. I don't even use it in the course except for this one demonstration. All right. When you run it, okay, the first print will be the value 45, there's no question. The second print is basically going to tell you the memory location of the variable, okay? The memory location, you won't be able to predict. It's going to look like a random number, okay? But it's going to look like something. So there you go. So the value is 45, and it's stored in memory location 2811612. End of story. It's just a memory location. You would have learned this from infs 1101 that every variable is in a different piece of RAM. That's perfect. All right. So the actual number itself isn't important, but what's your prediction on this? I'm going to print the memory. I'm going to print the values. Not a problem. Everybody understands this. I'm going to print the memory location of x here, and I'm going to print the memory location of x right here. It should be the same. It's the same variable. But in the world of Python, it isn't. And the reason for this is because integers are immutable. You can't actually change them. So what happens is on the very first line, when you said x is equal to 45, it set aside some space to put a 45 in it. Later, when you said x is equal to 54545, it actually had to throw out the original one and make a brand new one. Okay? Now, again, I'm not going to ask questions about this. Don't worry, this is just to deal with an explanation about one term. I would now like to make a small change to this, and I'd like to talk about my test scores again. So here we go, test scores. Okay, 64, 85, all right, there we go, some test scores. I'm going to print the test scores. Okay, that's not a big trick. You're going to see what we've got. I'm going to take the test scores, and I'm going to append a new test score at the end. Okay, we'll append 100 at the end, and I will print the test scores again. All right, this is not a trick question. You know what's going to happen here. You're going to see all the same scores, but the second one is going to have the 100 at the end. That, of course, is not what I'm interested in. I'm really keen today on the ID of the test scores. Okay, again, a single ID by itself, it doesn't mean anything. Oh, and by the way, if I run this a bunch of times, I might get different values, because it's up to Python to decide where does the value exist. Every time you run it, it may say, okay, it's going to go here. No, this time that's busy. I'm going to use this one. That's why you keep seeing different memory locations. You can't predict them. It's nothing really for 1201. However, the following thing is kind of a bit more interesting. All right, so, test scores. Okay, it's a little bit different. Okay, but we'll try this one as well. All right, so what I did was I took a test score. On the very first line, I said to something, I'm going to prep the memory location, and on line number 4, I'm changing it. So if we apply the same logic we just applied to numbers, integers, we should end up with a different memory location for test scores in the second time, but instead, it's exactly the same. That's because lists, I said I would use arrays occasionally, lists are mutable items. You can modify them, okay? And it's a little bit weird because you think, yeah, but I can modify integers, but they're handled internally in a very different way. And this whole ability, whether or not it's immutable or not, makes some really, really surprising things. Okay, so that's why it's got to be here. Same thing. Oh, and by the way, if you simply said, okay, now the test scores is equal to these, you can see now that it's changed because I made it a brand new one. So you can't just replace the entire thing, but you can modify the individual contents without creating a new one. That's what the word mutability means, and I know that it's never well covered anywhere. All right, however, if things are mutable, they get some really weird properties. Okay, so what do we have for mutable items? So far, we have lists. That's the only mutable thing we have. Everything else so far is immutable. Floats are immutable, strings are immutable, integers are immutable. End, okay? Lists are the first things that are mutable, and as a result, when you start to deal with mutable items, you get completely weird and I don't want to call it unpredictable behavior, but it might be some unexpected behavior. All right, so what do I mean by this? Okay, simple thing to start with. Value is equal to 500. Print value. Okay, next up. Other is equal to value, print other. Other is equal to 400, print value. Okay, I suppose this would be like an infs 1101 question. What is the final output? Okay, well, in fact, let's just ask for what's the output of this program. All right, line number 2, that's going to be the first print statement. What gets displayed? 500, very good. All right, next one, line number 4, what's this going to be? 500, that seems pretty reasonable. Then we're going to modify other to be 400. I'm going to print value. 500 because I changed other, not value. Okay, good. Yeah, that's exactly what it is. Okay, I was thinking I was expecting something different. All right, good. That works exactly as you expected. Okay, test scores. Okay, here we go. We need here we go, 59, because that would probably be definitely a something that, let's not do that, 87, 90, 90, 95, and a couple of small ones of 45. Okay, that's fine. All right, so here you go. There's a bunch of test scores. All right, print the test scores. Okay, we'll do it one piece at a time. Obviously, if I print it, it works exactly as you expect. Okay. Okay, second time I print it. Same thing. Well, it doesn't say same thing, but it says exactly the same numbers. Okay, excellent. All right, so we've got this. Now, somebody would like to modify score 0 to be, well, okay, the complaint will be make it 60. Okay, and here we go. I'm going to print, actually. Here we go, the updated. All right, and I'm going to ask the question. Okay, I was talking about the most recent one. On the third display, the line number 6, what do we expect to see? Exactly, the same, no, but what do you mean the same? What's the first score? It should be 60. Okay, excellent. Okay, good, that makes a lot of sense. And you know what I'm going to do as well is I'm going to print the original test scores. What's the first score? 59, okay. So let's run this one, and unfortunately, you'll notice something really weird just happened. Okay, wait a minute. I had 2 different lists. I changed one, but the other one changed. No, it turns out you didn't have 2 different lists. You had one list. Well, right here. We said updated is equal to test scores. Okay, well, here's the rule. When you use an assignment operator with a mutable object, you don't get a new object. You get something called an alias. It now has two names. It's one list, 59, 70, 87, 90, 95, and 45, but there are two names that are referring to it. Here, give me a second. Let me make a brand new slide. Normally what I would do is, if I had a whiteboard, I would draw the following picture. I don't have a whiteboard, so you have to deal with some artwork over here. Okay, so first of all, I'm going to have to make an array. I'm not going to put numbers into it, however. Okay, not quite. There we go. All right, sorry, I'm calling it an array again. I have a list. How many elements are in my list? 4. Okay. Okay. You know what? I can put in some values. Here's a 3. Here's a 6. Here is an 8, and here is a 2. Okay. Excellent. Now, if I had a whiteboard, I would draw it this way. I would then take an arrow, and I would put an arrow right here. Oh, sorry, I'll put it the other direction. Okay, I would point here, and I would call this test underscore scores. Okay, and I would draw this picture and say, there you go. That's actually what it means. There is a variable called test scores, and it refers to an array which happens to have 4 elements. The elements 3, 6, 8, and 2. Done. All right. This statement right there, updated is equal to test scores, because lists are mutable, here's actually what happens. I get another variable, but it refers to exactly the same spot. Okay? Other. So now what I have is I have 2 variables that refer to the same spot. So if I change test scores, I'm really changing other. And if I change other, I'm really changing test scores. Okay, have to watch out for this. And it's a very, very important thing. That's called an alias. You have 2 items referring to the same place. We don't have this problem with integers or strings or floats because they're all mutable. No issues. But when you have a list, or eventually we have some other data structures, all the interesting things we do here, if you use an assignment statement, you end up creating aliases, and that can cause you an enormous amount of headache. Because imagine if you really wanted to hang on to the original test scores and you just want to see what would happen if you change the score. Like, what's the pass rate if I add 1 mark? But you still want to keep the originals, because maybe you have to throw it out because it wasn't a valid check. Well, the problem is that if you modify it, well, then it modifies the original. Oh, okay. So unfortunately, we've got a bit of an issue. All right, that's the first thing. Second thing about sort of the fun stuff about mutable objects. Okay, another fun fact. Oh, here we go. Here's some fun. Okay. Remember what that is. That's just a temporary placeholder. I'll come back to it in a second. Okay, here we go. Test scores. Okay, we will stick in a 59, a 70, an 87, and 9. I don't even care what these values are. Okay, here you go. And, yeah, sorry, it's finger slipped. All right, there you go. All right, I wasn't quite ready for it yet. Okay, value is 45. Okay, fun value, print value. All right, so there's a fun function. All right, so right now, basically, this scores has nothing to do with anything. Okay, I'll come back to it in a second. So obviously, there's something special that happens with lists. All right, so the program runs like this. Very first line is line number 5. It creates a list. We don't use the list ever again. Then we run line number 6. Value picks up the number 45. I come down to line number 7. Where do I go? Up to line number 1. What's the value of data? 45. Okay, good. And it's function calls. On line number 2, data becomes 46. 46 because you add 1 to it. If you want, I mean, I can print this as well. So here we go. I'll just call it fun and I'll print out data so you can see that it actually did work. And then, of course, I return and then I print value. What gets printed is a 45 or 46? 45. Good, you guys learned that from last semester. Yeah, because if you modify a parameter, it has nothing to do with anything else. Okay, excellent. Okay, on the other hand, I'm going to pass in scores. Scores is a list. Now, obviously, I can't add 1 to a list, but what about this? Okay, so think about what I've done. I'm going to call the function. I'm going to change the very first element to 99. Used to be 59. It's going to be changed to 99. So the person, in fact, will make it really stand out. For some reason, they got a value of 100. And out here, I'm just going to call this main and value, just so we know which one we've got. All right, there's absolutely no question. All right, you pass in scores as data. Data is now that full list called scores. This line right here modifies the first element to be 100. So when I print it, what's the first element you see? 100. Okay, good. Then I return. All right, I return back out to here and I print value. What's the first value?
59.
Yeah, it should be 59, right? Because, I mean, that matches what we just did a second ago. Okay. Unfortunately, if you're thinking it's a trick question, of course it's a trick question. Ooh, I actually have to spell it correctly. Value, scores. You should have just told me you crashed. Sorry, scores. Okay. All right. Here, we'll run it. You notice something weird that happened. I called the function, I passed in a value as a parameter. The function did something to the parameter and it actually reflected out in the main. Why? Simple. It's a mutable object. It works just like the assignment statement. When you call the function, data picks up the value, but if it's a mutable object, it actually picks up a reference. So whatever you're doing to data, you're really doing to scores. It's the same object. It's the same picture that I had a second ago. Completely unexpected, isn't it? Okay, well, sorry, now it has to be expected because this is the way how it works. Why did they do this? Okay, I'm sure the people who wrote Python were probably thinking, what could we do to mess up a first-year programming student? Let's do this. Okay, no, this is not the reason why they did it. The reason why they did it is because when you call a function with a big list, it takes time to pass in the list. So instead of copying the entire list inside, they said, well, let's just use an alias because it'll be faster. Have you ever done something because it's faster? Of course you have. And this is what they've done with every programming language, by the way, has exactly the same issue when you're dealing with lists or arrays or whatever they're called in the language. It was done for efficiency purposes, but it can be a surprise because your function now causes side effects. It's kind of like a global variable. It's a little bit nasty, but this happens. Okay, so if you have a list and you pass it in as a parameter to a function, the function modifies it, you're really modifying the original list. If you use an assignment operator, exactly the same thing. You're creating aliases. And yes, if I do something like this, if I say data append 300 at the end, yeah, we're talking about adding a 300 to the end of the original one. Okay, so there is only one list. Something you have to be very, very cautious about. Okay, what if I don't want it? Well, if you don't want it, then we've got other issues. All right, so if you really want to have a duplicated copy of something, it's up to you to copy it yourself. Okay? So remember what this was. I had scores, and I had updated, which was equal to scores, and I said, go to updated, add 0, and make this equal to 60. And of course, the problem is that I print scores. Okay, so now the function is being ignored. We'll come back to that in a second. What's the first entry? Yeah, 60, because it has been modified because of the aliasing. All right, if you really, really, really want to have your very own copy of the data, the good news is it's actually pretty simple. There is a method built in called copy, and what it will do is it will make an exact copy of your list, and it will be your own to do whatever you want with. They're now completely detached. Getting kind of noisier out there today. Okay, I'll wait. Okay. All right, so when you copy something, literally what you're doing is making a clone. Okay. That operation that I just right there, that's the copy. Okay. Very, very different. So why don't we just use copies all the time? Speed. Okay. It's all about speed. If I point at my arm doing this, it means about time. Okay. Yeah, it's obviously going to be slower doing this than if you just have an alias, but maybe a little bit dangerous. It's a trade-off. What do you do? What do you do? Do I pick this one or this one? Okay, it really depends on what your function is trying to do. It depends on what your code is trying to do. There's no right answer to this. Okay, so sorry, it's not just a simple little thing. All right, so there you go. That's, oh, and I've got a second one. So yes, you can simply use a copy. Let's see, this one right here. Of course, this one was changed by the function. That's actually not a good example. So here we go. We will have to do the same thing. Okay, so let's do this. Let's call the function fun. Fun scores. Okay, the problem with this is out in the main. Okay, here we go. Out in the main, what's happened to our scores? Will it be modified? Will it have that ugly 300 at the end, which seems like an invalid piece of data? Yeah, it will. Okay. Yes, it will. And of course, it'll look like it inside. All right. If you want to work on a copy of it, you have a whole bunch of different things you can do. You could pass it in and you can actually say the word copy. So what goes into the function is a copy of scores. So it gets modified all you want, and the original stays the same out in the main program. Okay, so you have this option. All right, so there you go. There's one technique for copying. There's actually a second way of copying, which seems incredibly, incredibly weird. But here you go. So in case you really like this, that's the other way you can make a copy. Wait a minute, that's list slicing. Yes, it's list slicing. Where does it start? At the beginning, and where does it end? At the end. And whenever you do a list slice, it makes a brand new list. Okay, and that will do exactly the same thing. Okay, so yes, that did actually run. I suppose I could clear the output and let it run. So you have the option. If you'd like to type .copy, or if you want to use square bracket colon, you can do it. When would you use it? I guess if you want to make it absolutely clear what you're doing, you'd use copy. If you want to make it look cool so that when your friends ask you what are you doing, you don't know anything about programming, it looks more cryptic and looks more tech. Entirely. Oh, it's also only 3 letters, so entirely up to you, whichever you want. So square brackets with a colon, that's fine. It creates a copy through aliasing, whatever you'd like. Okay, so that's pretty good. Okay, let's do this. Let's have some more stuff. All right, so here we go. Scores, section 1. Okay, so here's some test scores for section 1. Okay, and here's some scores for section scores for section 2. Okay, there we go. Here's some really low scores. No, actually, I'm not going to do that. Here you go, because I have people in section 1 and section 2. All right, so we have section 1, section 2 scores. No, these are not real scores. They're just made up. What if you wanted to put everybody together? So I'll just put them all scores. Okay, how do you put these things together? It's a technique you've already seen before. The technique is called concatenation. Okay, you've seen it with strings. So if you have 2 strings and you want to put them together, what do? Yeah, stick a plus. You stick the first thing that you want, so scores section 1, and you say plus scores section 2, and if I print all scores, yes, there's a function called all. We will not do that now. You'll get a combination of both of them. The order will not be disturbed. It will be exactly the order that the original score 1 and score 2 were in, and of course all of the stuff from score 1 will show up first, followed by all the stuff from scores 2. Okay, concatenation, exactly the same as what we saw with strings. Okay, so nothing funny about this. There is an alternative way of doing this, because we need lots of alternative ways. Here we go. although it's a little bit different. Okay, this one right here, if you ask to extend a list by another list, it works exactly the same way as concatenation. There you go, so same thing. Which of course then somebody will say, yeah, but when do we know which one to use? Whatever it is you're trying to do. The extend modifies section 1, but the concatenation doesn't. Okay, so it depends on the problem you're trying to solve. Do you want to have a brand new list with the result, or do you want to take something and extend it? One thing I have to watch out for, okay, because, and by the way, I've always thrown in questions like this. All right. Here, let's get rid of this for right now. And I'm going to ask the question, if I do this, what does it look like I'm trying to do? I'm trying to stick a 77 at the end. And that's exactly what happens. So here, what I will do is let me run print scores section 1. Here you go. There's the before and after. Oh, it's kind of like an append. Yeah, kind of like an append, but not quite. Okay, here's the result of this one. Now, unfortunately, it gives a somewhat cryptic error because it talks about an int object not being iterable. All right, I mean, I understand what it means. However, here's the deal with the extend function. It doesn't take regular arrays. It doesn't take a regular value like an int or a double or anything else. It takes a list. Okay, so you can only extend a list with another list. On the other hand, if I did an append, now it's back again. But you have to watch out, because if I try to use it like this, you get a big surprise. Yeah, it turns out it's a list inside a list. Okay, so you have to watch out for this one. In fact, if I did something like this, now you can see that what I'm doing is I'm appending a brand new list at the end of the list. Oh, that's a nested list. And that's exactly what was just said. It's a list of lists. Well, sorry, this isn't a list of lists. Remember what I said is that you can put whatever you want inside a list, including other lists. Okay, a couple of lectures before we get to this. Let's deal with some easier things first. Just be very, very cautious about this. Append means one element. Extend means to take a list of things. Okay, what have we got next? Danger with list extension. Oh, that's exactly what I wanted. Okay, excellent. Now we go on to some very interesting, and the good news is very, very easy things to deal with. Okay, there's a bunch of built-in functions that are very, very handy. Okay, so here we go. Here's the first thing I'm going to ask you. Oh, that's made it too simple. All right, here we go. Out of that list of scores, which one is the smallest? 12. How'd you figure that out? I looked. All right, what can we do? Okay, if we wanted to do this, how do we find the smallest? Okay, the way how it works is you start with something like this. You start with smallest being equal to a really big number. You go through each of the elements. So I'll say for S in scores, and I will say if S is less than smallest, then the smallest is equal to S, and then you do a print smallest at the end. There you go, 12. Excellent. That's the usual thing. We've been through this exercise before. Now, because this happens so often, quite often you are looking for the smallest, or the biggest will be almost exactly the same. The good news is that the people who made Python said that, yeah, you know what, this is going to happen all the time. So they created a function called min. And the way how it works really well with lists, is you just do this. There, we'll clear this output, and there you go, 12. Excellent. That was easy. Too bad it wasn't so easy in the other case. All right, oh, and what else do we have? Okay, well, you know, the equivalent one is the largest. Take a guess. Yeah, that's exactly it. The maximum of scores, and we'll print the largest. Okay, there you go, 89. Yeah, and it will go through. It actually solves the problem exactly the way that we've done it. Okay, there's no difference whatsoever. So you say, great. Do we get to use these on tests? Yeah, of course you do. But guess what? I will never give you a list of integers and say find the smallest. I may give you a slightly modified version of that and say, give me the smallest even number, because you can't use the min function directly for it. You have to actually write some code for it. But if you do need the minimum because it's part of another problem, yes, you are certainly allowed to do this. In fact, I would encourage you to do this. Okay, and maybe we'll see some examples of this. All right, we have a bunch of test scores. Likely, what you'll probably want to do is somebody will probably say, yeah, you need to calculate the average of these test scores. Okay, how do you calculate the average? How do you calculate the average of a bunch of test scores? Yeah, you add them all up. Okay, very good. So for x's integral is sum is equal to sum plus x. Yeah. There's a reason why we haven't been using the variable called sum. Yeah, guess what it does? Oh, but I have to spell it correctly. Here you go. Yeah, it's 425. I trust it is. Okay, take the numbers and add it up. Yeah, don't worry, it will be. All right, and of course, if we're interested in the average, how do you calculate the average? Well, it's the total divided by the number. Oh, how do you figure out the number? Well, it's called length. So the length of the scores. So here you go, print the average. The very last number will end up being the average. So it's kind of a little bit low. People should do better. All right, so just above 60. So yeah, these are really, really useful because these are things that people do all the time. But as I said, it's not something that I ask you to do on tests because, well, one-liner? Yeah, sorry, you're not getting 20 points for one line. Maybe it would be like it makes a good MCQ question, but that's really about it. Okay, but if you do need the sum of something, yes, certainly use sum. If you need the minimum or the maximum, by all means use these things. They are here for you. All right, now I've got to do a few of these things. Okay, I won't worry about this one. Oh, no, this should be lots of fun. Okay. Num scores, sorry, I'll keep this in scores. All right, so what are we printing? Better print it as well. Print num scores. Okay, so there you go. There are 7 scores. The smallest is 12, the biggest is 89, and the total of everything's 425. Excellent. All right, what if somebody comes along and they end up with a 56.8? Is this going to be a problem? Yeah, a list can have anything. Okay, so there's no problem on line number 1. But now my question is wait a minute. Can I still figure out how many elements are in the list? And the answer is, yeah, of course I can. It's still 7. Is there the concept of a minimum? Yeah, I mean, the minimum is still 12, right, even with the 56.8. The biggest is still 89, even with the 56.8, because I can compare the 56.8 to everything else. Yeah, this ends up working completely fine. Okay, so a combination of ints and floats, no problem. All floats, no problem. All of these things work. Unfortunately, if I start to include other things, and I think I've used these before, like for example, if you were to drop the course rate now, your transcript will show a W. All right, so if I ask you which one of the scores is the smallest, is it the W or is it the 12? Yeah, is it the 12? Now, that's a pretty reasonable thing. However, when we run this, we end up with a whole pile of trouble. All right, the very first thing, how many items are in the list? That's easy. Python knows, okay, yeah, well, there's 8. I can count that there's 7 commas, so therefore there's 8 values in the list. Okay, excellent. But unfortunately, when it comes to finding the minimum, you can't do it because it doesn't know how to compare a string against an integer. In fact, that's exactly what it says. I don't know how to compare to see whether or not something is less than a string and an int. The same thing will be true of max, and the same thing will be true if it's a whole bunch of strings. Okay, so you can't have mixed type. You can have the mixed types, but you can't use mixed types and use either the min, the max, or the sum. Length, no problem. All right, so in that case, what about this? Just because I don't feel like trying to write up other things, I'll just completely take what I've got here already. All right, so, okay, print the length of words. Ooh, now this is going to be an interesting thing because it could be a little misleading. What is the length of the words? 3. Yeah, there's 3 words. I'm not talking about the length of each individual word. I'm talking about the length of the thing called words. Words is a list. There are 3 of them. Okay, no problem. All right. What the heck does that mean? The minimum of the words. Let's see, that's pretty easy, right? It just doesn't work. Apple, why? Because A comes first. That's exactly it. What happens is when you do this, it is using something called lexicographical comparison. And basically, it's the order that things would appear in a dictionary. That's the quick way how to deal with it. So Apple will come first. All right, and if I ask in this case, let's try a couple of extra things. Let's see, what do we want to have? Okay, an ant. Which comes first, apple or ant? They both start with A. Yeah, okay, good. Ant. Okay, here we go. Microsoft Azure. Yeah, Apple, because obviously the AZ will come afterwards. All right, good. So you got the idea behind this one. And what about apple pie? I know it's not a word, but we'll pretend it is. Yeah, because the shorter versions of the word shows up first. If you open up an English dictionary, what's the first word you find? A, or whatever you want to say it. And of course, we're talking about what is a word, like that type of thing. All right, and of course, if you ask for the maximum, yeah, cherry, because it starts with a C. All right, now one kind of quick little danger thing. Okay, I don't ask this on a test, but we'd better know what it is. Okay, so they said, here we go, an ant. Yeah, this will be fine. If I run this, what do we get? Ant, okay, good. Yeah, which comes first, the apple or the ant?
The apple.
Okay, why?
Because uppercase.
Uppercase letters come first because I'm not sure if it's covered in infs 1101, but in terms of comparison, it's based on something called the ASCII order. Okay, uppercase letters come before. Don't worry, I usually don't ask this type of question. You have to memorize this, but it's a good thing to keep in mind, especially if you're doing programming. The uppercase letters come first. Okay, because, what now? Yeah, so, okay, and again, it's because the uppercase A comes before the lowercase z. Okay, all right, so that's pretty simple. Okay, oh, perfect, so we have this. So if you take an apple, here, we'll make it actually legitimate. So if you take an apple, a cherry, a banana, and an ant, it wouldn't be very pleasant to eat. Okay, so it's not a good recipe. But if you sum them all together, what do you get? A cherry, apple, blah, blah, blah. No, you actually get an error. It's because you're not allowed. Sorry, I know you think that it's going to be concatenation, but it doesn't work. Okay, sum only works with actual values. Okay. All right, how are we doing? We're burning through our time like crazy. All right, so you might say, all right, so if you have all of these things, why do we bother showing you the other techniques? I mean, think about this. I mean, I already showed you, you would have seen them in 1101. How do you go through and add a bunch of things together? All right, well, let's actually bring this up, because if you got the sum function, you don't need to know the algorithms at all. Okay, well, here's the deal. So let's take some amounts. Okay, I'll pick exactly the same exercise as what I've got here. All right, so there you go. Here's a bunch of amounts. Okay, and yeah, if you wanted to calculate total, yeah, you could get away with saying sum totals and print the amounts, but do you think, I mean, if this was actual prices, do you think you'd want to possibly include the negative values? Probably not, okay? So, so can you use sum? And the answer is no, you can't use it directly. Yeah, unfortunately, because you're looking for certain things, you might have to do something like this. You might have to have a total which is equal to 0. You might want to have to go through all of the amounts. So for A is okay for an amount. A in amounts, I could ask the question if A is bigger than or equal. I guess bigger than 0, doesn't matter if it's equal. I could say that total goes up by A, and at the very end I can print total. You still need to know these because sometimes you're asked to do these types of things. Add these things up, but ignore certain ones. So if the question was, yeah, add these all up, but please ignore the negative values, this is one technique. There's another technique as well, however. Let me see if it shows up on the next page or if I'm just making stuff up here. Yeah, no, that's fine. I can do this. All right, I don't think it shows up yet, but I think it shows up a bit later, and I don't mind if I do this a couple of times. All right, so nobody wants to do this, right? Nobody wants to set up these accumulator loops. Okay, if you don't like it, this is also a very typical way. Okay, this is going to be the positive amounts. There's a bunch of them. I'm going to start off with nothing. I'm going to say for A in amounts, if A is bigger than 0, I'm going to go to positive amounts and I'm going to say append A. Now, what I'm going to do is I'm going to show you pos amounts. Okay, what do I have? I have a list with only the positive values. Oh, which means, can I sum them up now? Yeah, now I can. There, now it's easy. Okay, and yeah, this is a very, very common technique that we do. If you're looking for something because you need to do some analysis, either sum, min, max, whatever, yeah, you go through and you build up a list containing exactly the things that you need. Now it's easy to work with because you have things like sum, min, max, and whatever else. Length is also there. Yeah, now you can use those things. But it's, as I say, that's the type of question that would show up, not give me the sum of all these values, because that's a one-liner. Okay? And I would never say, give me the total, but you can't use the sum function, because I think that's an unrealistic requirement. Okay? So I'd rather actually put a real thing, which is, yeah, we need to add these up, but you have to ignore some of them. Okay? And this is the way how you do it. There's a couple of slides in here that also show you for finding the largest element in a list and the small list. It's the same concept. I've already done one example. There's one final exercise or one final slide that I do want to talk about, and then we'll do a couple little MCQ questions just for complete fun. And here we go. We've got ourselves, grab this whole thing, and I will show you one of these evil things that sometimes happens. All right, it's going off the end. Let me press enter so we can see it. I will put it like this. Okay, so now we can see the information. Oh, okay, and we'll even put it here. All right, what is this? Well, it says mixed data. Okay, maybe mixed data. Maybe I could turn this into something a little bit more interesting. Let's call it, these are iPhones. Okay. All right, what does this data mean? Maybe it means this. There are 45 red iPhones available, 300 green ones, because nobody wants to buy green ones. There are 18 blue and 20 purple. Okay, that seems pretty reasonable. And for some reason, all the data is being mixed together into one list. First of all, is it allowed? The answer is yes. Does it happen? Sometimes it happens. Sometimes you go to a data source and they give you data that looks like this. There are better ways of representing what I just described, but this is one way. But the question that I might have is, okay, if you wanted to go through and add up and tell me how many phones there are in total, how would you do this? I'm not talking programming. I just mean if I gave you a calculator and said, I want to know how many phones there are in total, what would you do? You'd grab your calculator and you'd add red plus, 45 plus 300 plus 18 plus 20. Okay, excellent. That's the algorithm. So in other words, you're picking every other one. Now, there are several ways how this can be done. So we will do several different ways. All right, the first one up is total. All right, let's go through all the items. Oh, but you see, I need to know, is it at this position or this position? Is it at this position and not this position? Okay, well, here's an easy way. Notice that all of the strings, the colors, show up in positions 0, 2, 4, divisible by 2. And the things that are not divisible by 2 are the prices. Okay, so instead of going something like this, instead of going through all of the phones in iPhones, because I have no idea where I am, here's what I'm going to do. I'm going to go for index in range of length of iPhones. Okay, first of all, I'm just going to print the index. Okay, you've seen me do this before. There's all the indexes. All right, I'm going to print the index and I'm going to print the iPhones at index. Bang, there you go. Yeah, so the numbers that I'm interested in are positions 1, 3, 5, and 7. Odd numbers. So let's add something. If the index modulo 2 is equal to 1, I'm going to print it. Okay, good. So now I've isolated. I only see the the values. I'm missing all of those names. Perfect. That's what I want. Instead of printing them, what do? Well, I would say that total is equal to iPhones at index. And at the very end, I can print the total. There you go. So there's 20. Very important. It adds. Okay, total is equal to totals. So here you go, 383. And I think if you add up those numbers, it'll be okay. All right, that's one way. Okay, yeah, you're basically using the index and you're saying if the index is odd, pick this number up. If the index is even, maybe you're trying to do something else. All right, that's fine. That's one approach. We've got a whole bunch of other really cool approaches that we can use, however, and there's a concept in here called splitting interleave data. Okay, let's get rid of everything. There we go. Let's not worry about the total yet. Okay, remember there are two types of data. The first is the names, their colors. Okay, that won't work, will it? Because it'll give me absolutely everything. All right, but I'm only interested in every other one. Well, I hope you remember something from 1101. You probably looked at it and said, well, that's kind of cool, but why would we do it? In fact, I think I even said it here. Okay, it has to do with list slicing. Okay, that's a copy of everything. That's still a copy of everything. But remember, start at the beginning, go to the end, step by 2. It gives me exactly the colors. Okay, how do we pick up the prices? I guess it's the quantity. How do we pick up the quantity? Exactly the same idea. Oh, but we don't start at position 0. You start at position 1 because it'll be 1, then 3, then 5, then 7. And now what I've got is if I print the quantity, okay, there you go. And how do you add up all the quantities? There you go. Yeah, see? So there is actually a purpose for having those weird list slicing things with the step size at the very end. So it's kind of a clever technique. And I mean, there's a slide in here. It's not revealing anything. I put it in. And once you extract these things, well, now you can start looking. And if you got negative quantities, you can ignore them. So you build up your programs this way. Okay, again, it's problem decomposition. I've had questions like this on the midterm before, and of course students are just trying to write these huge massive loops, when in reality it was really quite simple. And if you simply do a couple of print statements to see what do I have, can I turn it into something simple like a list of integers, then it makes your life considerably better. Okay. All right, so there will be lots of exercises. There will be exercises like this in the lab as well. I've made sure that there's some this time. Okay. That's it for the slides, except for I think one slide that I didn't cover. Okay, so give me a second and we'll see now whether or not you've been paying attention. Okay, so this one is about the things that we just did. Okay, it shouldn't be too bad. Okay, what do we got here? 34. Okay, we can get a couple more people in. Apparently 40 is the magic limit. Okay, Python expert, you better end up doing well. Ah, test scores, excellent. Okay, the other word which I haven't seen yet is blah, and yes, I will use that an awful lot. Okay, 38, I don't see too many more, I'll give you another couple of seconds. Okay, there's a 40, I probably can't get too much more than that. Usually they will cut us off at 40. Okay, so off we go. Alright, so all of this stuff I looked, and it was pretty much based on the things that we had just done. So weird, where's my irritating little sounds? There we go. Oh, I forgot to check the timing. Okay, hopefully there's enough time in each one. Okay, good. So most of you learned, yes, it's aliasing. Okay, so not this one here, not the red one, because remember it's an alias. Whatever you're doing to LST is really doing to my list. Okay, so that's okay. So I will put it this one. Assume that was obvious. Ooh, that one didn't work out so well, did it? Okay, we better take a look at this one. All right, so a couple of people picked 4, so what did I do here? Yeah, I mean, obviously the biggest number is 10, right? That, of course, is if they're integers. These are not integers. These are strings. Dictionary order. 10 comes before 4. Okay, so unfortunately, yes, you have to watch out for this one. If you've ever seen some instructors in D2L naming their assessments as Lab 01, Lab 02, Lab 03, and so on, the reason why they're doing that is because there are certain things which you can't control the order, and it's sorted alphabetically. And it literally, if you say Lab 1, Lab 2, Lab 3, Lab 11, it'll put the Lab 11 before Lab 2. Quite often people will stick zeros in front of it. Okay, so that's why. So yeah, the 4 is actually the biggest surprise. Okay, here we go. Next, and next. Okay, a couple more and then we will be done. Okay, it's a good time. What was I doing? Question too that was on this. I'm hoping that this one should be pretty decent, yeah. and again, so you got the idea that there's an alias, but this one actually returns the list, and of course this is the thing that gets printed. It didn't print my list, but yeah, that one should be quite straightforward. Okay, number 4. Good. So the slides are certainly working. All right. So yes. So this playing out, X is the value 1. 1 goes in at the very last location, and we discovered that even if you make the position really, really big, it still works and it adds to the end. Okay. Excellent. All right. So one more, and then we'll be done. Okay, so not so great. Okay, but it wasn't terrible. All right, I better take a look at this one for a second. All right, so I know you're looking at this one. Which one was it? It was the blue one that everybody went for. All right. Which one did we go for? No, sorry, it was this one down here, the orange one. The correct one was blue. Okay, so here we go. Why did we go for the 30, 30, 20, 52? Okay, pretty simple. You saw the 1 colon, so you immediately thought, okay, it's a list slice ignoring the first element. Very good. You would have gone through and you would have said, yeah, well, it's adding 10 to each of those items. Like the last 3, not the first 1. Okay, but remember that when you take a list slice, it makes a copy. So therefore, as a result, you're not actually modifying the variable called data. You're actually just modifying the thing called A. Okay, so there you go. That was preventing the aliasing. Even though, yes, it's a small bit of it, but that's what a list slice does. Is it creates a copy. Okay, so that's the reason for it. Okay, so there you go. And now you can see who's won. All right, thank you, and we'll see you. I guess it's next week. Okay, Python expert. No. Number 4 for Python expert. Sure.
Exercise with the list that's next with strings and numbers.
Oh, yeah.
If I did for loop that inside it asks if for A and whatever, if A is digits and then I added them and incremented it, would it be?
No, you won't be able to do that because what's going to happen is when you hit an integer and you ask for a digit, it's going to say, oh, I don't have a function for that. What you need to be able to do is you need to be able to figure out what types things are, and that's not something we cover here. Okay, but what you'd have to do, you'd have to look at the actual type.
I don't understand why it wouldn't work.
Well, the issue is if you ask the integer 5 if it's a digit, it doesn't have an is digit. That's something that exists for strings.
Oh, okay.
So
okay,
it would
yes,
actually
yes,
crash
yes.
and say, no, I'm
Yes.
not going any
Oh, I
further.
got it.
Yeah, so instead what you need is you need to be able to find out what type something is.
Mm.
There are ways you can do it, but it's not something we do in this course.
Okay, thank you.
Yeah, it's very difficult to work with mixed data like this, especially if you know that they're coming in positions. It's easy, but
Yes.
if you don't know what's coming,
That's why I thought
yeah.
we could do that.
Yeah.
Thank you.
Okay. So the only thing about not tapping the card and signing is the system will mark you absent, and I put it back. Okay.
No, it's alright.
Yeah.
I forgot my card.
Yeah, no, no,
I
it's-
looked at it and I was like, I'm gonna put it in
Yeah.
my bag, and then
Okay.
I forgot. And then I have 3 classes today, so I've been paying just for my other. Thanks so much.
Okay.
Have a nice day.